My name is Curtis Oakes. I'm a Process Technical Associate at BN National Trail. It means I am very knowledgeable of what happens out here in the plant. I know the whole system. I learned most about the equipment from doing inventory. I touched every piece of equipment out here. All this equipment was actually back there in our laydown yard, so I got to see it all erected, all the pipes be put together. So then I used the P&IDs to go through, and then I eventually kept building and building and building, and now that everything's pretty much put together on the skids. So there's 3 chemicals that start at the very beginning, which is our soybean oil, our methanol, and our sodium methylate. Our soybean oil is going to go into skid 101, which is directly behind us. The soybean oil is going to get introduced to this skid. It's going to get heated up within the tank. Once it gets heated up, it's going to go to the second level up there, and it's going to get heated up again and then make its way back out to the pipe rack. The other 2 chemicals are sodium methylate and methanol. The methanol is going to start at the tank farm. Same with the sodium methylate. Once it leaves the tank farm, the 2 chemicals, they'll run into the skid directly behind us with the two tanks. Both chemicals are when we drop into the tank, they're going to be mixed within the tank. The 2 chemicals, which there is going to make our catalyst. Once it makes a catalyst, it's going to go to the second level over there, and it's going to get heated up and off the skid and rolls to one of our 4 reactor skids. The soybean oil, which has been heated, and the catalyst, which is the 2 sodium methylate and methanol, have been mixed together, will run into the reactor. Once they go into the reactor, they get sucked up the reactor, they'll leave the reactor and then that's considered our biodiesel. This one skid right here can do about 10 to 12 million gallons a year. If you turn another one on, it can do about 20 to 30, and then if you turn another one on, and so on and so forth. After it turns into biodiesel, it's going to run through a heater. It's going to go to the top of that tank. It's going to get mixed even more. Once it gets mixed, it goes through a plate and heat exchanger. It's going to heat it again. It's going to run around to the centrifuge. Once it hits the centrifuge, it's going to throw out our glycerin or methanol out of the mix. The glycerin is going to go down to the glycerin distillation column. The biodiesel is going to come out, go through 2 filters, and then down to the ion exchange skid. Once we produce about roughly 50 million gallons a year and we need to produce more, we will set another reactor skid, which then we can run about 60 million gallons a year. 60 to 65 million gallons a year if we introduce another reactor, we want to build another reactor skid. The biodiesel is going to come out of the centrifuge as well, and it's going to go through a couple more filters. Once it does that, it's going to make its way down to the ion exchange skid, which is going to remove our soaps out of our biodiesel. Once we remove our soaps, we're going to go to our other biodiesel distillation column. The distillation columns will pull the methanol out of our system. This is our methanol regeneration skid. Basically, any methanol we take out of the biodiesel or the glycerin, we will send the methanol to the very top. We'll suck any other one of the vapors out, glycerin or biodiesel. It's basically purifying it so we can send it back to the front of our system. This system can reuse about 94% of all its methanol. There's very little waste, yes. Once it gets introduced to the distillation column, we're just going to remove any excess methanol that's in the biodiesel and just purifying the biodiesel so we can send it to our biodiesel holding tanks, and then that's where we're going to add as a buffer so we can send it out to a rail car. It comes pretty natural now, yes.